I've built my own front-end framework from scratch, and the first thing it taught me is that you don't actually need one. The browser already does everything a framework does. It reads HTML, it draws the pixels, it listens for clicks. The browser has never heard of a component or a state or a virtual DOM. We invented all of that and we invented it for a reason. So here I'm not going to define what virtual DOM is to you. Instead, we are going to do something better. We will start with a clean page and no framework, and then we'll break it. And every time it breaks, we invent the smallest possible thing that fixes it. And then by the end, we won't have a pile of features, we will have a framework, and you will know exactly why each piece of it is there for. So let's say here we have a button that counts clicks. Now, count is our data, and the button is what the user sees. It's a view. When the click event fires up, we bump up the number and then we update the button text to match it. Two lines for this, and honestly, a framework would just get in the way. So let's make it hard. Now, picture a to do app. The data isn't one number anymore, it's a list. Each to do has a text, whether it's done, maybe a priority. The screen isn't one button, there's a list. A little counter of how many are left, a footer that only shows up once something's finished, an empty message when there's nothing there at all. Watch what it takes to add a single to do. The data part is trivial, push it onto the list and done. The screen is where it falls apart. I have to build the row, its text, its button, wire those buttons up, drop the rows in the right spot, and hide the empty message if it is the first one, and then update the counter and maybe wake up the footer. So for adding a one to do, I had to do seven different things here, and then the delete is seven different jobs again, and then for the edit we have another set of jobs. So for every single thing the user can do, I had to write twice, once for what it does to the data and once for what it changes on the screen. Now look at the delete function. Half of it is about to-dos, the actual idea, and the other half is about the page, which nodes to yank, which label to fix, what to unhide, and then second half is the half that grows and breaks. It's the half that now I'm maintaining forever. I've got the truth in one place, my JavaScript, and the second copy of it, the view painted on the screen. Keeping those two in sync by hand on every single action is already a lot. Now suppose if I add a new feature, any feature, before I write a line of it, I first have to go and find every view that touches this data. Write fresh sync logic for each one, and the small app that's just annoying. But in a real one with dozens of you all depending on a same handful of numbers, it turns into a mess nobody can keep straight in their head anymore. It's entirely a mess. So how do we kill that problem? There are two obvious ideas, and both are wrong in a way that's worth understanding. The first idea, be surgical. Only ever touch the exact things that change. That fast is literally what we just did, and we saw where it ends up. The descriptions of the page get smeared across hundreds of tiny different functions, and every new feature means hunting all of them. So then we have a second idea, the opposite of it. Let's be clever entirely. Anytime something changes, let's throw the whole page away and rebuild it from the data. Like, see the render function here, and the code for is lovely. It takes the state and then builds the entire view based on the state. We just describe what the page looks like for a given set of data. We never write an update function. We never say now go and change that label. We say here's the page and we say it every time. That's a style has a name. It's called declarative programming, and it's exactly what we want. Then we run it and it collapses because inner HTML doesn't update the page for small changes. It bulldozes the entire page and builds a brand new one. So for every node get thrown away and replaced by a stranger that happens to look exactly the same. If the user was typing in the box, gone. If something was focused, that is also gone. Now, if they scroll the page halfway down and then we update it, now that is also gone. All of that lived on real nodes, and we just deleted every one of them. We rebuilt the entire page to change one number. So now we know precisely what we are after. We want the lovely part of these two ideas. Just describe the page from data with the machine being smart like the idea one, actually touching what really changed. And describe everything and change almost nothing is basically what we want. So then how can we do it? The thing is the move that gets us both. smaller than it sounds. The trouble with inner HTML is that it's a string. We can't usually compare two strings. We can't ask what's the difference between old page and a new page when the both are just text strings. So let's not use strings. Instead, describe the page as a simple JavaScript object. Suppose we have a button like this. So it becomes like this. This is a virtual node. It's not a real button. You can't click it. It has no size. The browser never sees it. It's just a small description. There should be a button here. The tag should be the button, and the prop should be the class primary, and the children should be the safe. A whole page becomes a tree of this virtual nodes, which we call virtual DOM also. Now, our framework doesn't actually want you typing objects like that by hand. It will be a tedious job. So there's one small function that builds them for you called H, short for hyperscript. Same object just built by a function instead of typed out by hand. And page isn't only buttons and text. Sometimes it's a few virtual nodes that need to sit side by side without an extra wrapper holding them together. So that's a fragment, a virtual node that's no tag of its own, just a bundle of children. And now because all of this is an object and not a string, I can hold two of them. The old page as it was and the new page as it should be. And I can walk both and find exactly what changed. People make the virtual DOM sound like a magic and like some speed trick. It's neither. It's just this. Describe the page as cheap data, cheap enough that we can rebuild the whole description on every change. So machine can line up the old description against the new one and work out the tiny real difference. Some frameworks don't do it this way. Svelte, for instance, works out the changes ahead of time, back when it compiles your code. It's just the path we are tracking because we can watch every single step of it happen. And also, this is how the author of the book decided to do it. Okay, so we can describe a page as objects, but objects doesn't show up on screen. Something has to walk that tree of virtual nodes and build actual DOM. This step is called mounting. It's exactly what we do by hand. See a text node and make it a real node. See an element node, create the real element, set its properties. Then we do the same for each of its children and slot it into the page. But mounting does one thing that makes a big impact later. When it builds a real button for a node, it writes that real button back onto the node, like it does here. Now, node isn't only a description, it's a description that remembers the exact real thing that created it. Now, hold on to that. It's a thread the whole system hangs from. We are going to come back to it later. Now, let's move on to state. A component is just a bundle, some data, a render function that turns that data into those virtual trees. Read what render is saying. Give me a count, I am a button that shows it. It doesn't touch the screen, it just describes the view. So, let's follow one single click all the way through. On a click, the browsers run increment. It bumps the count, then calls update state. Update states run the render again and right there, and that hands back a new tree. Same button except now it says count 1. But that new tree doesn't touch the screen either. It goes and sits next to the old one, and the two of them gets handed off together as a part we have been building together the whole time. The part that finds the difference between them and touches only that. That part, the one responsible for finding the smallest difference between the old tree and the new tree, is called reconciliation. Before it can find what changed, it has to answer one question. Are these two nodes even the same thing? Now, do they look identical? Are they the same node or just updated ones? The rule is simple. Same kind of node, same tag, a button and a button. This is the same button. Keep that real one and fix only what differs, like the text, a class, or whatever. And button and a div, they are not the same thing at all. So delete the old one and build the new one. And when it is the same, this is where the element we stashed earns its keeps. The new node doesn't build anything. It reaches for the real node the old node was pointing at and changes the one thing that actually moved. We described the whole page. We changed one character, one real node, a node that's been sitting there the entire time. keeping its focus, keeping the user cursor exactly where it was. So the user's world never got rebuilt, it just got nudged. We keep saying a component, but defined component doesn't just hand you a component, it hands you a class basically. Every place you actually use that class becomes its own separate instance with its own private state and lifecycle hooks. Put two counters on the same page and they never touch each other's count. Click one and the other doesn't budge. That independence is the whole reason components are worth having. But a state is only half of what a component is. The other half is that it's alive. It shows up on the page, it sticks around while the user does things, and eventually it goes away. And every so often you need to run a bit of code at exactly one of those moments. The code that has nothing to do with the component, with what the component looks like. Take a to-do app. The moment it appears, it should load whatever to-dos you saved last time out of the browser storage or from an API. Every item at the list changes, it should make a patch or a post request to the server. Neither of those is what do I look like. Neither ones belong in render. And render actually can't be where they go because render runs on every single update. It's meant to stay pure. Describe, don't act, right? Uh, Drop a read from storage into render and it fires again on every keystroke. Drop a save to storage in there and you are hammering the disk for no reason. So component gets a few extra hooks. Named moment where you hang code that should run once and at the right time. The to-do app hangs on mounted, load on mounted, and save on state change. That's the entire persistent story. Appear, load, change, save. So we have this life cycle hooks. On mounted, on state change, on props change, on unmounted. But there's one subtlety. It's a reason this is trickier than it first looks. On mounted has to run after the real DOM exists. If the thing you want to do is focus an input or measure how tall something got, the element has to actually be on the page while render is running. It isn't there yet, right? So the framework doesn't call on mounted on the instant you mount. It schedules it to execute right after the real nodes are in place. A real page isn't one component, it's a tree of them. The to-do list owns the array. Each row is its own small component, with each having its own delete button. So when someone clicks the delete on four, uh, fourth row, suppose, how does that reach all the way back to the array sitting on the parent? The tempting shortcut is to just hand the child a reference to the parent and let it reach in and change the list directly. Don't. The moment you the moment the child knows the shape of its parent, it stops being a reusable row and become a row that's only work inside a specific list. So data only moves in one direction at a time. Down, the parent hands the child prop, here's your ID, here's your text. Up, the child never touches its parents. It just announces what happens. So we use emit. The parent back when it created that child already decided to be listening. The child has no idea who is listening or whether anyone is. It just says that what has happened. The parent gets to decide what that means. Same rule both directions. Props flows down and events flow up. The whole tree of component nested inside each other and not even one of them reaching into each other's internal to get anything done. So that's the way we do it. There's more, and I will go fast because once you see the pattern, it repeats. Slots let component leave a hole in itself, but like put your content here. So you can build a reusable card without the card ever knowing what's inside it, right? And then we have the routing, the thing that swaps pages when the URL changes without the reload. Turns out not to be the second system at all. A link click becomes a URL. The URL becomes a match, the match becomes a component and that flows straight back into the exact render and reconcile group we already built. The router is just one more thing feeding data into the machine. Now I didn't dream it up out of nothing. I learned it from a book, build a front-end framework from scratch. What it did was built it myself as I read, and then I keep going after the book stopped. I refactored it, I found and fixed many bugs. And then I added new things top of it, new lifecycle hooks, name slots, browser history router, and the tools, and the entire new CLI tool that scaffolds a whole new project for you in one command. And then I published it. So it's called Betal-FE. It's real and it's on NPM. You can install it right now and then use it. Now, is it going to replace React? No, that was never the point. Betal-FE is a lab. The whole point is small enough to hold in your head at once, and you can open any file, read it top to bottom, and actually follow what's going on, what it is doing. So it has no giant runtime, no hidden machinery, nothing you are asked to trust. It's just built to be taken apart. When something breaks, you don't have to file a ticket and wait. You can just open up a file, fix it yourself, and that's not the framework failing to you. So that's a framework working, because every time you fix it, you understand a little more, and it's for the kind of person who'd rather know how their tools work rather than just use them. That's also what building it did for me. I don't look at the front-end framework the same way anymore. When a child fires an event up to its parent, I know exactly what just crossed the line, and based on what mechanism it has built on. So when a state changes, re-renders, I know precisely what's being compared to what. And when something feels like magic, I know the move now. Find the data, find the thing that owns it, follow it down until it hits the real browser API. There's more, there's always a bottom. There's no magic. Somebody just built it. And now so have I. One last thing, this is the first video on the channel, and you just watched is a map, a whole framework seen from above. Almost everything I flew straight past into a whole new story sitting under it. How the diff actually knows a list item moved instead of vanishing, how URL quietly becomes a page, how the framework picks exact the right moment to run its code. I'm going to take those apart at a time, each in its own separate video. So if there's one you want first, tell me in the comments. So Betal-FE is an open source. It's meant to be poked at. Read it, break it, send me the thing I never thought of. Everything, the code, the docs, the books that I started it is in the description below. So thanks for watching.